All right. Welcome, everybody. Can you all hear me? Wave if you can hear me. Wave if you can hear. There, I see you. Awesome. Thanks so much for being here. Today is our last live video feed from Grouper Moon 2016. And with us today is Bryce Simmons right here, who's quickly going to reintroduce himself for those of you that might not know who he is.
Hi, guys. Welcome. Again, name is Bryce Simmons. I'm a professor at Scripps Institution of Oceanography, and I've been the lead researcher for the Grouper Moon project here for almost a decade now, almost 10 years.
Awesome. And you may be able to tell from where we are that we're not on the boat and that we are not underwater at the aggregation site. So can you tell us a little bit about why that's happening?
Sure, yeah. So I don't know if you can see it. I'm going to turn the camera a little bit so you can see out. And I bet you guys can see the clouds in the gray sky. Can you guys see that? Raise your hands if you guys can see the clouds in the gray sky. Okay.
Yeah.
Well, behind those clouds and gray sky is a whole bunch of rain, and it's coming in from time to time. And with those clouds came a lot of wind and high seas and even currents, which means water moving quickly past the dive site where we're at. And all of that makes very unsafe conditions for diving. So that's kind of the way it goes sometimes with field science, where we can't predict exactly what the weather is going to be like. And even if we could, these fish spawn come storm, high winds, high seas. They'll spawn anyway. So we can't really base our science on the weather. And it just so happens every once in a while the weather gets so bad we can't go out on the boat. And today, unfortunately, is one of those days.
Yeah, so the researchers went out this morning for an early morning dive to see how things were going with the grouper, and they did see grouper out there, right?
Yeah.
But you also noticed that there was pretty high current, which for some of you younger guys, you might remember current would be kind of like wind underwater.
That's right.
And when it's super strong, it's really hard for Bryce to be able to talk and swim and not get blown off into the current at the same time. So we have to make that call for safety reasons. So instead of being out there, we've pulled together a bunch of really amazing and cool clips of Nassau spawning and of the aggregation site that we're going to share with you. We're also going to share some videos from a test that we did yesterday of a special kind of camera. And we'll talk about that after we show you a few of these clips. So the first clip I'm going to show you, just hold tight. I'm going to do a screen share for a second. You'll see nothing, and then the clip will come up, and it will show you what the aggregation looks like typically. Okay, so there is the full moon right there. And that's what several thousand grouper look like all together. And I'm going to ask Miss Damon's class to hit the mute button on their camera. Thanks, guys.
So as you guys are watching this, you'll notice that some of these fish have really, really big bellies. And they look kind of like, almost like they're bloated, or they've got air in their stomachs. Well, it's not air. Most of those stomachs are filled with millions of eggs. They've got a huge amount of eggs that they'll ultimately release at the spawning site.
And what is that diver doing there?
Yeah, so that's a diver that's taking some, collecting some data, and they're attempting to count all the fish that are out there. And that's what a spawning burst looks like. You guys, I assume, all saw that. That's pretty amazing, right next to the camera. So here you're going to see a series of different spawning bursts as they happen. And that's where the female is releasing her eggs, and then the male comes along after and fertilizes those eggs. And then after about 24 hours or so, about a day, those eggs hatch and turn into tiny fish, and those tiny fish swim around in the ocean, out in the currents and waves, up until about a month later, when they get large enough, just about that size, where they can settle back onto the home reefs, and then they become a reef fish, just like a very small version of the big ones you saw out there.
Were you guys able to see that video? Can you give me a wave if you were able to see it? Yeah? Okay. And were you able to hear us talk while we were showing that? Awesome. Okay. So that's one video. Now I'm going to show you when the grouper come, and this is one of the coolest things, I don't typically get to go dive in the evening time on the aggregation. It's a challenging dive. But during the day, and especially on the days leading up to the spawning event, there'll be this highway, a ribbon of grouper that are constantly joining the aggregation. And this is a clip of what that looks like. So there you can see there's just this band of grouper, and it will happen like that for days, that we'll see that as the fish are joining the aggregation site.
So one of the things you guys can do while you're looking at this video is think to yourself, how many fish am I looking at? Because that's what we as divers have to try and do while we're out there, is estimate how many fish there are. And you can see just by looking at it, it can be a real challenge to come up with an accurate number for how many fish there are just by looking at the aggregation site.
And you can see there's a few scientists back there that are lasering and counting fish.
And each one of those fish is probably about 2 feet long, maybe about 1/3 of a meter long. So those are all very large fish.
And a couple of the questions that I've gotten on the blog had to do with coloration, and it looks in this video like there's a lot that still have their bar pattern. Does that change as they get closer to the actual spawning event?
Yeah, so most of the ones that kind of look almost like they're pearly, those are white-bellied, and then white-bellied phase, and then you see the ones that are black on the top and white on the bottom, and they've got a white eye stripe through their eyes, and those are bicolored phase. And the bicolored phase is the most common phase on nights when most of the spawning, actual releasing of the eggs takes place. And so we can use the ratios of different colors, how many bicolor to how many white belly there are, as an indicator for when they're going to ultimately release their eggs.
Let's see. All right, so that's a cool video. We're going to stop that there. All right. So you guys there got to see some cool, big, massive grouper. Now, a few times we've had drop cameras that they've placed on the site. Can you tell us about what that means?
Sure. Yeah. So, we have a lot of different sciences happening out there all at the same time. Some of which relies on divers like myself and the rest of the Grouper Moon team to go out and deploy the equipment live. Oftentimes, however, we can do small things like take, for instance, a GoPro camera and put it out at the aggregation site and then press go. And it can sit out there for a couple hours, or depending on how we set it, it can last for almost up to a day. And during that time, when there still has power, it's collecting data, it's collecting images that we can later on take back to the lab and analyze so that we can come up with things like estimates of how many fish are out there.
All right, so we have this really beautiful, it's about 2-minute film that I'm going to show you, and I want you to try to count how many different fish species you can see out there besides just the grouper. The grouper will be out in the background, and then you're going to see some interesting fish in the foreground. So pay attention carefully to this. And for those of you who have been studying will know that there's some soft corals there in the foreground. Oops. And, oh, there went something pretty cool.
Yeah, that's I'm sure you guys probably caught it. Just went off to the right of your screen. That's a southern stingray. Those guys can get up to 4 feet across on their discs. They can get really big. And we see them sometimes as divers, but not that much. So it was really, really surprising that we caught that on a drop camera or camera that we'd set up and left out there.
Oh, I hope you're seeing what I'm seeing. A lot of you have asked if we've seen these on the dives. What do we have up here in the water column, Bryce?
Yeah, up in the water column, up where the sun's kind of glowing, those are horse-eyed jacks.
Oh, there's our shark.
Yeah, right in the middle there, that's a Caribbean reef shark. And we'll see those sometimes out here. And in fact, those sharks are out here to hunt the grouper. So out at the aggregation site, the grouper aren't the top predator. It turns out that sharks often are the ones that are trying to prey on the grouper while they're out there to spawn.
Awesome. All right. Oops. Okay, so you guys saw that shark. Did you see the shark? Raise your hands if you saw the shark. Okay, so like Bryce just said, sometimes those sharks are pretty busy out there on the aggregation site, and we'll try to catch a fish. And I've got some video of that if you'd like to see that. You guys want to see a shark trying to go after some grouper? Let's see about that. Okay, here we go.
So when you're watching this video, pay attention to the grouper that are in the background that are shooting up in a spawning burst. They're all shooting up together, and they look like they're going to release gametes or eggs. And right when that happens, if you look carefully, you'll see a shark in the background, and he's going to attack those grouper as there it is, and woof, there goes that shark. And now you're going to see the shark swimming up onto the reef. You kind of see him there.
So he's right, kind of in the middle, right there. So I'm going to show you that video again because it's at night, right? That the aggregation that they're spawning, so it's harder to see them. So let's go back and watch one more time. Let's see if I can make this screen bigger. Okay. All right. So he's going to come from the background.
He's going to hit those fish in the background. Ugh.
And those fish were, yeah.
Now, fortunately for the grouper, or unfortunately for the shark wasn't successful at getting any grouper on that particular attack. But that's what the sharks do out there. Oftentimes they'll wait for those grouper to go in a spawning burst, so they're rushing up to release those eggs, and the males are rushing up following those females to fertilize those eggs, and they're really paying attention to that and not paying attention to the sharks around them. Well, that's a really good time for the sharks to get up there and try and get a tasty grouper to eat.
All right, so I bet that some of you guys have some questions before we move on to any more clips of what's going on out there on the aggregation site. So if any of you have a question, you can let your teacher know, and your teacher can let me know in the group chat window, and we'll call on you, and you can get up and ask a question to the camera. All right, I'm going to let you guys. Oh, Inbar has a question, so we're going to go to Renaissance. There they are. And you'll want to unmute your mic.
Done.
So,
You gotta be loud.
So you mentioned something during the last video about something called a horse-eyed jack. What is that?
Yeah, horse-eyed jack. Big question. A jack is a silvery fish. There's many different species of jacks in the tropical waters and some that are in temperate waters. But out here, one of the most common jacks is horse-eyed jack. They get to be about that big, maybe a little bit bigger. So almost the same size as a Nassau grouper, but they're a pelagic species. And what that means is they spend almost all of their time up in the water column where they feed they're typically fish feeders, but they feed on fish as up in the water column. And so they spend a lot of time on the edges of shelf breaks and in areas that are right at the interface of the coral reef and the open ocean, where there are lots of plankton pickers or smaller fish that eat the plankton that come in off the open ocean to the reefs themselves. But they're silvery, and you probably saw that in the broadcast, because that's their ocean environment. They're in a deep blue ocean where there's not a lot of reef structure that they can blend in with. So the best thing to blend into open ocean water is to be silvery.
And why does that help them blend? What do they do with that silver?
Because they almost look shimmery. So if you're, for instance, a shark and you're attacking a horse-eyed jack and you're coming up from below, that horse-eyed jack, because it's silver and shimmery, is going to look a lot like the water up above the shark, and so it's going to have a hard time getting at it.
Wonderful. Great question, Inbar. Now, let's see, does Denise's class there in the Bahamas, do you guys have a question? All right, you can unmute your microphone and you can ask a question. So your microphone is still, there we go. Hello. Oh, I can't hear you. All right. So if I can't hear you guys, so maybe you can have your teacher type your question into the chat box.
Okay, and while the teacher is typing that question into the chat box, I have a question for you all, and that's what's with the green stripes on your faces?
Yeah, I'm not sure if everyone can see that, but it looks like there's. Is this a war party, a hunting party? Are you guys going out catching wild boar?
Well, you can let us know with your text response.
All right. So the question is, who do you think is harming the groupers more, the humans or the sharks?
That's an interesting question, and the answer is really it depends. It depends on where you are. There are certainly some places in the world where grouper populations are quite healthy, and there are other places where grouper populations are very, very heavily fished, and it's easy to argue that they're unhealthily fished. We're fishing them too much, and I think there's a case to be made for the fact that some amount of fishing on these populations, as long as it's a sustainable practice, is an okay and a good thing. The problem becomes from the perspective of human harvest. If we take too many, if we overharvest the population, then we can really do great damage to the overall population health, not just locally, but in the Caribbean. Now, the reality is that Nassau grouper or any other species of grouper did not grow up in a vacuum, did not evolve in a vacuum. So as long as the species has existed, there have always been predators on it. Whether or not those predators are humans or sharks, we're all part of that same ecosystem. The real key there, the crux of the answer to that question is, can we as humans come up with a sustainable management practice that serves both fishing as well as ecological integrity or the health of the population and the reefs?
Okay. So it looks like the question now from Miss Meisel's class there in the Bahamas is, how many fish were in that video?
If I were to estimate just in that band that we were looking at, I would say probably about 900, maybe as many as 1,100, just around 1,000, I would guess.
And how many are you expecting total this year when the full aggregation is there?
Yeah, more like a 5,000. So wow. I mean, and you can imagine that, right? If you saw all of those fish that in that video, and that was approximately 1,000, imagine looking at 5 of those. It's a lot of fish, right? And that's good news, because it means the population here has really rebounded from its low point. But what's really interesting is that there's no evidence to suggest at this point that the population is anywhere close to stopping its recovery. If you look at the trajectory of their recovery, it's really going up quite rapidly. But that's exciting news for us, because it means the management that's been put in place in the Caymans is being very effective.
Wonderful. Okay, and it looks like Renaissance has some questions. And if you guys can unmute, why don't you come up and ask your question? We'd love to see your face.
Hey, come here, Leif. No, come on. Ask your question.
When will you next be going to the aggregation site to study the fish? And if you find, like, when will you be the one diving? And when are you going to find any? And if you find any, can you send us some pictures?
Are you asking me or Bryce that question?
Both of you, technically.
Both.
Both of you.
Well, I'm going to be flying. I'm flying later today, so if you fly, you technically cannot be diving. But Bryce was out this morning, and will be going out again. So how many more times do you think you'll be going out?
I think probably by tomorrow we'll have good enough conditions that we can start fielding the full team again, and we'll start going out and surveying the site again. But here's the deal, and we talked a little bit about this in the past. We thought, based on all of our prior information and all of our data, we were pretty certain that the fish would all be there at this time in this month, and that they would spawn. And guess what? They're not all there, and they're not spawning near as we can tell. And that's never happened to us before. So this is the process of science. We have to, we have a best guess or a prediction or a hypothesis, and we act on that hypothesis. And sometimes we get it wrong. And that's a learning experience for us, and it helps us to improve our hypotheses so we can come up with better ones in the future. And so it's an iterative process. And this
What does
year,
iterative mean?
iterative means you come up with a hypothesis, you test it, and if it's wrong, you change the hypothesis and test it again, and that's the process of science. We come up with hypotheses, we test them, figure out whether or not they're right or wrong, we modify our hypothesis if we're getting it wrong, and we test it again. And through that process, we learn. We learn what characteristics of the environment, of the time of year, of the lunar phase, ultimately help us better predict when those fish are going to be there and when they're going to spawn.
And it looks like Miss Redrup is watching us from the UK. We just want to say hi to Verity Redrup, who has been involved in the education program since we began. Really exciting to see that you're watching. So I want to also add to what Bryce just said. As a teacher, I'm not a scientist, but I get to be here on this project every year and see some incredibly intelligent scientists grapple with big issues. And one of those is the things that come out of left field that they weren't expecting at all, that can just come up, and watching them try to problem solve that stuff on the fly is really exciting, and it's really challenging.
It's one of the most fun parts of science, to be honest. It's frustrating, but it's really fun too. You get to be creative as a scientist. You know, people don't tend to think about scientists as being creative, but it really is. When you get down to it, it's a very creative process.
Cool. All right, and I think Andrew was ready for a question. Andrew, did you want to ask a question?
So what's the biggest lionfish you guys have seen, if you have seen any at all?
Okay. Excellent question. The question was, what's the biggest lionfish we've seen?
You know, we haven't seen many lionfish out here. We've seen a few, but not many, and the ones we've seen are not that big. You know, lionfish can get to be almost football size, some of them, but none of the ones out here. And there's probably two reasons for that. One is maybe a recruitment, or the settlement of new baby lionfish has not been very rapid recently. And the other thing is that the local dive masters here on Little Cayman, once a week they go out and they visit sites all around the island, and they cull lionfish. In other words, they go down and they spear as many lionfish as they can over the course of a whole dive. And they've been visiting most of the island on a regular basis. And by doing that, they've really removed most of the lionfish around the local reefs.
Yay!
That's pretty cool. You know, the first year that I came out here, we saw lionfish pretty regularly out there on the aggregation site, and on a lot of the shore dives that we would go on, I'd see many, and I'd see many that were, you know, pretty big and healthy looking. And then as you guys probably watched when we went out on Bloody Bay Wall a couple of days ago and did the dive there, I didn't see any lionfish. So that's a pretty cool thing.
Hey, I have a question for you guys. I know we've talked a little bit about this, but you know, when they spear and remove those lionfish, almost all of those lionfish get eaten. So the question is, how many of you, show of hands, how many of you have tried or eaten lionfish?
Oh,
just a few of you.
It looks like we've got some kids in the Bahamas there who have eaten some lionfish.
Look at the Bahamas. Look.
And they're good, huh? They're pretty tasty.
Yeah, you like them? Lionfish tacos, those are pretty tasty. So, Miss Meisel's class, if you have another question, you guys are welcome to type that into the window. And and the question's right there. How bad is the overfishing in the Cayman Islands, if any?
Great question. There's not an easy answer to that, and in part it's because there's not a lot of great fisheries data from here, at least more recently. But the Cayman Islands government has been very proactive at establishing parks and protected areas in an effort to manage the fishery here through protection, or setting aside certain areas of reef that are not allowed to be fished. And because of that, the Cayman Islands has some of the largest, healthiest populations of big reef fish anywhere in the Caribbean. And so while we can't necessarily say with a lot of confidence whether or not species in general are overfished or are sustainably fished, there's lots of evidence to suggest that they're better managed reefs here than most parts of the Caribbean.
All right, excellent. And then we have one more question from Miss Meisel's class in the Bahamas. How do you count the fish with the laser tool?
Yeah, so you guys got to see the laser tool, right? Did you raise your hand if you saw the laser tool? Okay, so we don't count fish with the laser tool. What we do with the laser tool is we swim around and we focus it on as many different individual fish as possible. And that video that we capture that has 2 red dots on it, that we know the exact distance between those 2 red dots on the fish, we can then take back to the lab and we analyze that data using some specialized software. And we can, because we know the distance between the 2 red dots, we can estimate the size of each of the fish that we have on focus in those cameras. And we do that hundreds and hundreds of times each year. And from that, we get estimates of the overall distribution of different types of sized fish. And so here's the question to you guys. If you didn't fish a population at all, so you never took any fish out of it, do you think that there would be more older fish in that population than a population that has lots of fishing taking place? Raise your hand if you think there'd be more older fish. All right. If there wasn't any fishing at all, do you think there'd be more older fish? Yeah. Yeah. So there would be. And because there would be more older fish, you would expect those fish to be bigger, right? Older typically means bigger. And so we can use the size class distribution, or the number of older, bigger, larger fish in the population, to say something about the recovery of that population. So it's not just all about how many fish are there, it's how old and big the fish that are there are.
Okay. Now, we're going to head back over to Renaissance, who has a question from Erica. We're ready for you. You'll want to unmute. Okay?
Are there any other species that you know of that are being protected the same way you protect the grouper?
Great question.
Yeah. Well, so Nassau grouper, which is the species that we're focusing on out here. And I should say that our research reaches beyond Nassau grouper. It's just that a lot of what we talk about is Nassau grouper because that's the most amazing and visual species that we work with here. But there are lots of species of grouper in the Caribbean and in the world's oceans that have varying degrees of impact associated with fishing. Nassau grouper are one that's listed as endangered under the IUCN, but as I mentioned in the dive the other day, another species of grouper that's also listed as endangered is the Goliath grouper.
And aren't there other restrictions protecting other species here in humans? Like, I thought conch and maybe lobster,
Mm-hmm.
and are there others?
Sure. Yeah, and if you move beyond fish, there are management plans. So there's seasons or windows of time when you can take conch and lobster. There's places where you're allowed to harvest them and places where you're not, and all of that builds into management plans associated with those species. All of that is aimed towards sustainable management of those species. When you talk about fish and grouper, in particular, I tend to think of Nassau grouper and Goliath grouper. And there are success stories not just here but elsewhere. A great success story is Goliath grouper in the Florida Keys. Right, that species was doing very, very poorly until protections were put in place in the 80s. And in the last decade, that population of fish, of Goliath grouper, has really done very well and is much larger than it used to be. So it's responded quite well to those management protections.
All right, great question. Let's do one more question from Renaissance, and then we have a couple more video clips I want to show you before we're done. So let's go ahead. One more question, Grace.
How old are groupers when they die of natural causes?
Great question. Great question, and we don't really know the answer. It turns out, let's get into just briefly, and it might be a little bit of a tangent, but how do you age a grouper? You can't exactly ask it how old it is, right?
Just the number of stripes on the side.
No, you can't count the number of stripes. But it turns out you can count the number of stripes on its ear bone.
And what's that called? That's the
otolith. So
otolith.
Inside its head, it's got a bone that's part, and we do too, that's part of its ear structure that helps it hear. Well, what it does is as the fish grows, it lays down rings or layers of bone, one after the other, as it grows, and as its ear gets larger. And when we catch that fish, we can pull the ear bone out of its head, and if you slice it in half, they look like tree rings, just like in a tree. And if we count those rings or those bands, we can estimate how old they are. So that's how we get at the age of fish. But what that means is you have to catch the fish and kill it, unfortunately, in order to get at how old it is. So it's hard to say exactly how old they get to be, but we can use that data to come up with estimates which what are called age and growth curves. And from that, for a NASA grouper, we could estimate that maximum sizes or ages might be anywhere between 30 and 40 years old.
Okay. And so there's a couple more videos that I want to show you guys that are really amazing. One is going to be of the actual spawning bursts, and you'll see some scientists going up into the water column and collecting some of the eggs that are in the water column, and then and we can talk about that. And then I know some of you were with us when we talked to Paul, another scientist on the project, who had created this really amazing microscope camera that would take photographs of plankton in the water. And I have some video showing you the first test launch that we did of that. So let's first look at the spawning. So hold on one moment. All right, so you can see here there's quite a few fish, and it's getting darker, so it's harder to see there. They tend to spawn at night, right at dusk. And you can notice now there's not many with that barred coloration anymore. You see a lot of the bicolor, or some that are completely black.
So that's me right there, you guys. That's me swimming through just off of the shelf edge where the fish are spawning. And you can see that piece of equipment I'm carrying. That's actually a net. So we'll capture some of these eggs that the fish are spawning, and we can take that back to the lab to look at things like genetics and fertilization rates, so we can better understand the biology of these spawning events.
A question that I've heard from kids before is, why do they do this, going up into the water column? Why don't they just let their eggs out at the bottom?
Right, yeah. So when the eggs themselves that they release, they're buoyant, and that means they float. And so what these fish are doing when they're going up towards the surface is they're helping those eggs get up to the habitat, or the place where they're best able to survive long enough in order to turn into larvae. At least we think. We're not 100% sure, but that's the best guess. But you'll see a bunch of fish all swimming up together and releasing that what looks like almost a puff of smoke. Well, that's one female releasing her eggs, and as far as we can tell, it's a whole bunch of males that are all crowded around that female, trying to fertilize those eggs as she's releasing them. And there you can see one of our other research colleagues, Scott, who you met earlier. That's Scott collecting some eggs as well.
Really cool. All right, so that is what it actually looks like when those fish are out there spawning, which is really pretty great. Now I'm going to show you the microscope camera. What is the name of the microscope?
We haven't even named it yet. If you guys come up with a great name, just let us know, and we'll throw it into the mix and contention for the name that we're going to ultimately use for this device, this contraption.
Okay, so here you can see I'm filming from up above on the boat, and below there's a number of scientists that are holding onto this huge camera that's attached to a winch on the boat because it's so heavy, and we're going to release it into the water.
And this is on the same boat that we were diving off of, the RV Seakeeper. This is the Cayman Islands Department of Environment Research vessel.
So there they've got the bottom in the water, and then you can see that plankton net that's going to be on top collecting all of the specimens that the camera's going to take pictures of. You can see everyone's pretty excited.
So this is, we showed you the divers collecting eggs by hand, and that's challenging. So this is the sort of evolution of that process, where we now have a device that we can tow behind a boat, and it can collect some of those eggs for us rather than us having to do it with divers. But the other really amazing thing about this is it's equipped with 2 different microscopes at the back of that plankton net, and those microscopes can detect depth. And so we can take pictures of all of the eggs and plankton that are going past those cameras and into that net.
And here it is underwater. You can keep talking,
Yeah.
but here it is actually floating in the water and collecting plankton. And then it goes down through that. I'm going to go up again, watch it again. It's going to go down through that net, and there's 2 cameras and 2 strobe lights down there that are going to take microscopic images of the plankton and whatever else is in that water, right there. All right.
And I'm really excited about that piece of equipment. That's something that's totally new and has a lot of potential to give us some really great insights into what's going on with the eggs once they're released. Because it's a really critical question for us: is what happens to the eggs once the fish release them? Do those eggs just float away and end up over in Haiti or someplace else, or do those eggs come back to the Caymanian reefs where they turn into more grouper here locally? And that's a really important question as far as the Cayman Islands is concerned. So it's critical that we try and ask those and address those questions. And this is just one of the tools we can use to get at that set of questions we have.
Okay, and so I had asked the scientists if they could get us a little clip of something cool that they saw in that microscope, and they did find this crazy crab, the microscopic crab. So I'm going to really quickly show you a picture that was taken last night when we deployed the camera. So hold tight. And here is our crazy microscopic crab. So one of the other scientists this morning was saying that we should put this to music because it does kind of look like it's dancing.
It does a little bit. Yeah. it's got its groove on.
Wow.
And that's something that you really wouldn't be able to see with the naked eye, and that's one of the advantages of this equipment is it can get very, very detailed information about things that are really too small for us to see with the eyes that we've got anyway.
That is super cool. All right, so let's get out of that, and we'll come back to you guys. All right, so there's some video that of the spawning and of the microscopic camera. Now, if you guys have some questions, we are ready. And it looks like Miss Mizell had a great idea for a name for the camera. Her idea is Planktonics, which I think is an absolutely appropriate name. And if anyone in Miss Mizell's class has a question, feel free to type that into the web chat. And we can head over to
Space probe. Egg collector.
Oh, I see. The Martian space probe, egg collector, and plankton vision are some ideas from Renaissance. Yeah. But now we have a little bit of time to take a few more questions. So if anyone has some, feel free to let me know, and we can come back to you guys. I know that I saw a few more people at Renaissance that had some questions they wanted to ask. If any of you are ready. Aubrey, it looks like, has a question. You can unmute your microphone.
So, on the reef, do you ever see any sharks and barracuda teaming up to hunt the grouper?
Oh, great question. No, but you know, barracuda and sharks, they're not in cahoots. They're not
good friends.
No, they're not good friends.
They're vying for the same food, aren't they?
They are. But it's kind of an interesting question because you know what species of fish is particularly good at cozying up to other species in order to catch food. That's Nassau grouper. So Nassau grouper will nuclear hunt or will get with other individuals of different species.
Like what kind?
Like moray eels.
Yeah.
Sometimes like sharks, like people, and they will follow them or shadow them and use the typical behaviors of any of those animals essentially as a camouflage. They'll shadow them and they'll use that to ambush other prey. By sneaking up essentially on the prey and darting out from behind the shark or behind the moray eel and grabbing the food. And then we think that's why it appears that Nassau grouper are so friendly to divers.
Wow.
So while barracuda and sharks don't do it so much, it turns out there are species of grouper that do that with other species of fish like moray eels and like sharks. Yeah.
All right. Excellent question, Aubrey. Let's see. Okay.
Go ahead, Sophia.
What's the largest predator on the reef that you've seen?
So the largest predator on the reef.
Okay. Now, the largest predator on the reef that I've seen, or the largest predator on the reef, period?
Which one?
That I've seen.
Mm-hmm.
Largest predator that I've seen would probably have to be a tiger shark. And that is one of the largest predators here in the Caribbean. Not the largest, though. I would have to say that the largest would have to be a transient killer whale, which I have never seen underwater, but they do show up sometimes in the Caribbean, and those guys they sure are predators, and they'll come. Used to be, for instance, when the monk seals were here in the Caribbean. They're not anymore because they're extinct, but undoubtedly when the monk seals were here in the Caribbean, those transient killer whales hunted in the Caribbean for those.
Wow. Yeah. I mean, killer whales are quite large.
Yeah.
All right. Let's see. Next question, Holly.
Hi. So it was like the question that Grace asked, how old are the fish when they die of natural causes? But like, then you said you tell them they're like tree rings. Which is the oldest one you've found?
Great. Yeah, the oldest. So I didn't do the work for the aging of Nassau grouper. That was actually Gina Ebanks, Petrie, and Phil Bush of the Cayman Islands Department of the Environment some time ago now. But I believe the oldest one they found was right around 30 years old. And that was from a fish population. So presumably in an unfished population, you would find some that are even older than that.
Okay. Excellent.
So you like talked about how little there are at the spawning areas or the aggregation sites. What's the most fish that you've seen at one spawning or aggregation site?
Okay, the most we've seen at the spawning site. What do you think?
Yeah. So as you saw, you guys saw that band of fish, and I asked you to kind of estimate in your head how many you think you saw, and I bet some of you came up with a couple hundred, and some of you came up with a couple of thousand, right? So it's very challenging as a diver once you get up past a certain number of fish, come up with an accurate estimate of how many are out there. And so we don't just use estimates from the divers. We use other techniques, like, for instance, tagging, in order to come up with more accurate estimates of how many fish are out there. And we think last year there was something like 4,800, so a little close to 5,000 fish at the aggregation site. Probably there's still that many again this year. We'll see next month when we get the full complement of fish showing up at the aggregation site. And that's a lot of fish. I should point out that is by far and away the largest aggregation left that we know of in the Caribbean. So this tiny island just below Cuba in the Caribbean happens to have, as far as we know, the largest population, certainly the largest density of Nassau grouper on home reefs of anywhere that we know of.
Of anywhere left on the planet, because they only live here in the Caribbean.
Yeah.
All right. We have another question over there. Are we all okay?
What % of grouper eggs survive?
The question was, what % of grouper eggs survive? That's a great question, Maisie.
Yeah, a tiny, tiny fraction. Think about it this way. The population of Nassau grouper is not growing, right? If anything, across the Caribbean wide, let's just say, let's say, best case scenario, we're at stasis. We're not growing, we're not decreasing, we're at the same population level. And we hope as scientists and as conservation practitioners that through time, that population will increase throughout the Caribbean. And in some places, like in the Caymans, here it is. But if we think about that population, and each female is producing millions of eggs, and if they're replacing themselves, producing one offspring that becomes successfully an adult, then that population will maintain itself at that population level. So if you go from millions of eggs, over its lifetime certainly, to one offspring that survives, your likelihood as an egg of surviving is pretty minuscule. Tiny, tiny, tiny.
Wow. All right. And it looks like we have time for one or two more before we're going to leave.
Four.
Hi.
Hi, Todd. On your blog, did you see my reply for the hawksbill turtle?
I didn't have a chance to reply to it. Do you want to tell us what you saw or what you found out?
I actually posted two replies, actually, like speeches.
Go ahead.
And I was going to ask if you had ever seen a tiger shark, but have you ever seen a tiger shark eating a turtle? And where do you get the t-shirt and hats that are really cool?
All right. So the question is about turtles, and I had posted the video yesterday of one of the hawksbill turtles that Hal saw on the aggregation site. So she's wondering who eats them.
Yeah, sharks, certainly. Tiger sharks would probably be, if I were a turtle and I saw a tiger shark, I would be trying any way possible to get as far away as I could from that tiger shark, because turtles are one of the most favorite treats of tiger sharks. So yeah, and some other larger species of sharks undoubtedly also eat turtles. especially hawksbills. Hawksbills are not one of the largest turtles in the ocean. There are much larger turtles in the Atlantic. Loggerhead turtles, for instance, and certainly the leatherback can get quite a bit larger. So there are several species of sharks, like bull sharks, oceanic hammerheads, that probably also eat turtles as well.
And we get those that come in through the Caribbean and through
Absolutely.
the Caymans regularly.
Yeah, more than we thought, until some tagging work has started to suggest that there are a lot more tiger sharks out there than we thought. It turns out that they're fairly shy, so they won't go near divers. And so as a diver, you don't see them that often, but it turns out there's a lot more than we knew just by looking as divers.
Cool.
Right. And Karen, go right ahead.
Go ahead, Karen.
You said that before there was some sort of extinct animal, like a monk seal or something. How did that get extinct?
Good question, Karen.
Yeah, Caribbean monk. So it turns out that the Caribbean used to have seals, just like on the west coast of the United States and out in the Galapagos and other places. But the Caribbean monk seal is no more, and it became extinct largely due to hunting in the early part of the 1800s and before that even. So it was a primary source of protein for sailing ships that were coming across the Atlantic. And if you're a big animal and people haven't had a lot of protein because they've been taking months to get across the Atlantic, well, the first thing they're going to do is stop off and try and get in a nice protein meal. And that was unfortunately things like the Caribbean monk seal and also the great auk. And so those large animals got eaten to extinction.
Okay. And then it looks like we have one last question from the Bahamas. How many fish on average are we seeing on the aggregation? And I'm wondering, maybe to add on to that, has it been changing over time?
Yeah, so it has been changing over time. The last couple of years we've been seeing several thousand more than we have in years past. When we started the monitoring shortly after a large fishing event that took place, which was the discovery of the aggregation site, there were probably maybe 1,000 to 2,000 fish at the aggregation site, and that population's grown almost tripled at this point. So large increases. This year, as we talked about, we're only seeing in the hundreds to maybe 1,000 fish out there, so not as many. But we think that's because this is not the peak month for spawning, and we plan to come out as scientists because we learned from our mistakes, and we're going to come out and try again next month when we think they will be spawning. And then we'll get a better picture for how many fish there are in the population.
Great. All right, well, we want to thank all of you guys for joining us today. It's been really wonderful talking with you. And we want to thank the Department of the Environment and Reef and the Disney World or the Disney Conservation Fund for supporting this project. Thanks so much, you guys.
Thank you.
And we'll see you again soon.